In this problem, we are comparing the height in feet of a tree compared to the time in years that it grows. So the first part we're asked is if the line of best fit provides a good estimate for the average height of a tree based upon how long it has been planted. Since the line is very close to a lot of the points in the scatter plot, we would say that that would be yes or true. The initial value is at 0, 5. Well, of course, the initial value on a graph is where the graph is crossing the y-axis. So that also is true. And point A is an outlier because it is far away from the line of best fit. Well, you can see that it is. If point A was down here, for example, then it would not be an outlier. But right now, it is an outlier. And then part number 2, it says, complete the statement below that describes the meaning of point A. Point A, in years, the height of a tree will be a certain number of feet. Well, years is the x value, so in years, point A looks like it is at 5 years. It will be a height of 14 feet. In this problem, we are asked to create a linear model by sketching a line that best fits the data. So we're trying to draw a line of best fit. Now remember, when we are trying to create a line of best fit, what we are trying to do is we are trying to draw a line that is as close as possible to most, if not all, of the points. So to me, that looks like that's a good line of best fit. And then after we get the line of best fit correct, it will ask us a second part. So it says, use your linear function to help predict the amount of coat sales in dollars if the temperature, it's a typo, if the temperature is 23 degrees Celsius. So 23 degrees Celsius would be about right there. And we're talking about an x value. So if we go straight up to our line of best fit and then straight over, we can see that that is almost 400. So probably maybe somewhere around 390. When we're doing line of best fit, we are simply giving an estimate. And so 390 will give us a close enough estimate for that. In this problem, we are comparing the dog's weight into its height, or by its height. We're comparing those two with the given scatter plot. So the first thing we're supposed to do is to create a line of best fit for that scatter plot. So remember, what you're trying to do is you're trying to draw a line of best fit as close to all of the points as you can. So that looks like a good one to me. And then we can go to part 2. Part 2 says, use your linear function to predict the height of a dog if it weighs 60 pounds. Well, pounds, as we can see, is referring to the y value. 60 pounds would be probably about right there. Remember, a line of best fit or a scatter plot is really asking for an estimate. So it looks to me like that's probably around 22 or 23 inches for a dog that weighs 60 pounds. And 23, you can see, is correct. In this problem, we have two fractions that we are trying to choose the appropriate equivalent decimal for these. So, of course, the first thing that we have to do is, if you don't remember that 67/99ths is an all-repeating decimal, then it's always top number divided by bottom number. And 99 is too big. It won't go into 6 or 67, but it will go into 676 times. 6 times 9 is 54. And then 6 times 9 is 54, plus that's 59. Subtract, and we can see that we are going to end up with 76 there. And then bring down a 0. And 99 goes into 767 times. And 9 times 7 is 63. 9 times 7 is 63, plus that is 69. Subtract, and we get 67. And you don't have to be a genius to see that that is just going to keep repeating over and over and over again. So there should be 1/6 right there. And so 0.67, where the whole thing is repeating. And so that would be all repeating, 0.67. We do the same thing for the other one. We've got 11 divided by 30, top number divided by bottom number. 11 is too small. 30 won't go into 11, but it will go into 110 3 times. That's 90. Subtract. Bring down a 0. 30 goes into 206 times. And 6 times 30 is 180. Subtract. And then you can see that the 6 is simply going to keep repeating over and over and over again. So that's a partial repeating, 0.36, where only the 6 is repeating. And that would be that particular part right there. In this particular problem, notice that it is asking us to approximate the square root to the nearest whole number. So square root of 115, we're going to surround that with the perfect squares 100 and 121. This is 10. This is 11. So we know that the square root of 115 will be 10 point something, but that's not the question in this one. The question is whether it is closer to 10 or 11. Well, it's 15 away from 100 and only 6 away from 121. So since we are asked to round to the nearest whole number, that would be closest to 11. In this particular problem, once again, we are rounding to the nearest whole number. This time we have a cube root, so we're going to surround the cube root of 67 with perfect cubes. The first perfect cube smaller than that is cube root of 64, which is 4. And the first perfect cube that is bigger than that is cube root of 125, which is 5. It's 3 away from 64 and 58 away from 125. Clearly, this is closer to 4 than it is to 5. In this particular problem, we're trying to figure out the square root of x is between 8.7 and 8.9. So what that basically means is we're trying to find the square root of something that is between 8.7 and 8.9. So we know that the square root of 64 is 8, and we know that the square root of 81 is 9. So we know we're going to be a little bit less than 9. So a good guess might be something like square root of 79, something like that. But if you want to be certain, one way of figuring this out would be doing 8.7 times 8.7, that's 49. 56, that's 60. 0, that's 56. 64, that's 69. And that is 75.69. And then 8.9 times 8.9, we're going to kind of do the same thing here. That's 81. 72, that's 80. 0, that's 72. 64, that is 71. And we get 79.2, I think that was 221. So what that means is that anything between 75.69 and 79.21 would be good. So we could use, if we wanted to, square root of 79 looks good, square root of 78 looks good, square root of 77 looks good, or square root of 76. Any of those would happen to be okay for this particular problem. And we're only entering the number right there, not the square root. So I'm going to go with 78 for x on that one. And so 78, we can see that that is correct. All right, in this particular problem, we need to remember the rule for multiplying exponents or multiplying expressions with the same base. We add the exponent. So technically what we're looking for here is 9 plus something coming from these two things right here. That has to be -5. That's essentially what we're trying to figure out there. And of course, for this particular problem, that would be -14. And once again, it's -14 because 9 plus -14 is -5. In this problem, we're trying to figure out what exponents can go in the blank spaces here and here, such that we will end up with 2 to the -12 power. Well, when we are dividing expressions with the same base, in this particular type of problem, we subtract the exponents. So you're trying to find some number minus a different number. That answer has to be -12. One way that you could do things would be like maybe like 2 and 14, because 2 minus 14 is -12. The other way that you could think about this is the fact that this is really the same thing as 1 over 2 to the 12th power, which makes this make a little bit more sense. So we will use 2 and 14. In this problem, we are trying to figure out what numbers we can input into the exponents there to make 1 over 2 to the 15th power. We need to remember that in a situation like this, we are adding exponents. And so if we think about this as being 2 to the -15 power, that makes this problem a bit easier. And so we could use something like -16 and +1, because -16 plus 1 is -15. In this problem, we are trying to figure out what we can input into the two blank spots where the exponents are to make 1 over 5 to the 6th power. If we recall that 1 over 5 to the 6th power is equivalent to 5 to the -6th power, that makes a problem like this one much easier. And so remember, when you have a power to a power, you multiply exponents. So essentially, we're trying to find two numbers that multiply together to make -6, like -3 and 2. There are other things you could use. You could use 2 and -3. Or you could use -2 and +3. Lots of different choices that you could use there. In this problem, we have the equation x to the third equals 27, and we're trying to figure out all the different ways of writing that as an answer. Well, remember, to solve problems like this, what we are really doing is we're trying to figure out what x is. And the way to turn x to the third into x is we take the cube root of that side. Well, we take the cube root of this side also. So cube root of 27 is one possible answer. And then since the cube root is actually 3, it could also be that. Now remember, cube root equations only have one answer or one solution. These are both the same. They are equivalent to each other, so that's still only one solution. In this problem, we're essentially trying to figure out which of these have an answer of 5. Technically, that means that is an answer of 5. Well, Square root of 5 is not 5. Square root of 25 is 5, so we would select this one. Cube root of 10 is not 5. Square root of 125 is not 5, but the cube root of 125 is actually 5, so we would be selecting both of those. In this problem, we have the equation x squared equals 81. Since we're just solving an equation, remember these type typically have two answers or two solutions. And the way that we solve these is, remember, we're trying to figure out what x is. The way to turn x squared into x is by taking the square root, so we also have to take the square root of the other side. Where we get the other answer from is square root of 81 is 9, so we know that we've got these two right here. But since 9 times 9 is 81, that's why we could have this and this, but also negative 9 times negative 9 is also 81. So that means we could also have a solution of negative 9, and working backwards from that, also negative or the opposite of the square root of 81. And I'm showing you why that is right there. So opposite of the square root of 81. In this problem, we have the equation x squared equals 26. Remember, in x squared equations, we will have two answers or two solutions. And we're trying to figure out really what x is. Remember, to turn x squared into x, we take the square root, and so we take the square root of the other side. Now, the square root of 26 is not a perfect square, so that would be one solution. Actually, this is 12, not 26. I'm not really sure where I got 26 from. So once again, 12 and 12. It's still not a perfect square root, so there's one solution. And then remember, since the square root of 12 times the square root of 12 is 12, and I need to back up here because I didn't even write this correctly. I'm going to use the right color pen here. That is square root of 12. Since that is 12, right there, there's one solution, but also since a negative times a negative is a positive, that's also 12. So we've got the opposite of the square root of negative 12. All right, so create an equation that has solutions of negative 12 and, or excuse me, positive 11 and negative 11. We have two answers here. Remember, equations that have two answers are always x squared equals, and since 11 times 11 or negative 11 times a negative 11 are both 121, that's what we would have there. Equations that have one solution, those are the x cubed type. And so basically what we need to do for that one is multiply 3 times 3 times 3, since this is an x cubed equation, and that is 27. So those are the two equations we come up with for the solutions that are there. All right, so the equation on the left, we have square root of x equals 5. What that technically means is we're trying to figure out square root of what is equal to 5. Now, obviously, hopefully it's obvious that that is 25. Looking at the other one, now we have a cubic equation. Cube root of w equals 4. We're looking for some number that if we take the cube root of it, the answer will be 4. Well, coming back to here, we could have multiplied 5 times 5 to figure that out working backwards. We could do the same thing right here working backwards. That is 64, so that means the value that we are looking for, that is W, like this one was X, is 64.